In example 4D, we're going to perform algebraic tests for symmetry on the equation y equals the cubed root of x. We did graph this equation out back in example 2D, so I'm going to flip back to the bottom of page 4 so we can examine the graph. Remember, the graph of y equals the cubed root of x is that snake graph. All right, so let's take a look and try to observe what type or types of symmetry this graph has, and then we will confirm our observations algebraically. So let's look at x-axis symmetry first. So imagine this were a sheet of paper that you're going to fold along the x-axis, so along this red dotted line. Would the top part of the graph lie on top of the bottom part? And the answer is no. Okay, so if you're looking at this segment right here in the first quadrant, if you're folding the sheet of paper, it should come down and lie in the fourth quadrant. And that's not what you have here. Okay, so this graph does not have x-axis symmetry. You can also make this observation by picking a point that's not on either axis. So for example, we know that the point 8, 2 is on the graph of the cubed root function. So if this graph indeed did have x-axis symmetry, that means the point 8, -2 should also be on the graph, because for x-axis symmetry, you keep the x coordinate the same and change the sign of the y value. And clearly that point 8, -2 is not on the graph. Okay, so there's no x-axis symmetry here. Okay, so let's take a look at y-axis symmetry. We're now going to fold the sheet of paper along the y-axis. Okay, so this time you would be asking yourself, does the left side of the graph, would it lie on top of the right side? Okay, again, the answer is no. If we looked at this particular blue segment in the third quadrant, if we folded the sheet of paper along the y-axis, then that segment would get sent over here to the fourth quadrant, and that's not what's going on. Okay, so no y-axis symmetry here. Okay, again, you can pick a point if you don't like visualizing it in that manner. Again, look at 8.2. We know that if a graph does have y-axis symmetry, then the point formed by keeping the y value the same and changing the sign of the x coordinate should also be on the graph. So that would imply -8.2 would be on the graph if this graph had y-axis symmetry, and that point is clearly not on the graph. Okay, so far no x-axis symmetry and no y-axis symmetry. Okay, now as far as origin symmetry goes, again, it's hard to visualize with the flipping, so let's just look at 8.2 and see where it gets moved. Remember, if you start with a point, then and you look at the point where the x coordinate and the y coordinate have both changed signs. If that point is indeed on the graph, then you're looking at a graph with origin symmetry. Okay, so we need to examine -8, -2. It is on the graph, it's right here. So this graph does have origin symmetry. Okay. All right, so let's go write down our observations. Okay, back on page 8. Okay, so for this particular graph, what we're going to be expecting is just origin symmetry. Okay, it's not going to have any x-axis symmetry or y-axis symmetry. Okay, all right, let's get started. We'll test first for x-axis symmetry. Okay, with this particular equation, we're dealing with a cubed root function here, and so there's no exponent. You've got a cubed root, and so we're not going to be able to rewrite the equation, like break it down. It's just going to have to stay as it is. Okay, so the radical is going to be challenging here. Okay, I'm just warning you, this will be a challenging example because of the radical. Okay. All right, so for x-axis symmetry, we know that if we start with a point xy, then the x value will stay put, and we're going to change the sign of the y coordinate. Okay, so we are going to go to the original equation, and everywhere we see a y, we are going to replace it with -y. So this is going to tell us -y is equal to the cubed root of x. Okay, like that. All right, so now we need to simplify this if we can. Okay, we need to compare apples to apples. So the original equation has y equals, but we have negative y equals. We want this equation to be simplified to say y equals, so we can compare it to the original equation in yellow. Okay, so to make this happen, I am going to multiply both sides by -1. Okay, so we're going to get this. All right, so on the left side, -1 times -y is going to be positive y. So the question becomes, what happens to the right side here? Okay, that radical may confuse things for you. Okay, so think about it. If you have -1 times something, it doesn't have to be anything complicated. Okay, think about just a number. Okay, if you had -1 times 2, what's going to happen? That's going to become -2. Okay, the negative just stays out front. If you had -1 times x, what's that going to be? The negative is just going to stay out front, so it's going to be -x. So this is going to turn into negative. It will stay out front, so you're going to get the negative cubed root of x. Okay, that's how this is going to simplify. Okay, so now you can compare it to the original equation. Okay, if you compare this blue equation to the yellow equation, they are not the same. The yellow equation has a positive cubed root of x, and the blue equation has a negative cubed root of x. Okay, so this is going to tell us, since this is not the original equation, this particular graph is not going to have x-axis symmetry. All right, y-axis symmetry. So to test for this, if we start with a point x, y, we know that y is going to stay put, and we're going to change the sign of x. Okay, so what we're going to do here is we're going to go to our original equation in yellow. Everywhere we see an x, we're going to replace it with -x. Okay, so this is going to tell us that y equals the cubed root. Instead of taking the cubed root of x, we're going to take the cubed root of -x. Okay, and that's it. Okay, you can simplify this, but it's not necessary here. You can compare the two for sure. If you compare the green equation to the yellow equation, they're not the same. Okay, there's a -x under the cubed root in the green equation, and there's a positive x underneath in the yellow equation. So they are not the same. Okay, so since this is not the original equation that we got back, this particular graph is not going to have y-axis symmetry. Okay. All right, lastly, we need to test for origin symmetry, and we observed in the graph that this will be a yes. Okay, this graph, the cubed root function, does have origin symmetry. Okay, algebraically, if we start with a point x, y, we need to change the sign of both coordinates. Okay. All right, so go to the yellow equation. Everywhere you see x, you're going to replace it with -x. Everywhere you see y, you're going to change it to -y. So we're going to end up with -y is equal to the cubed root of -x. Okay, and you know, we observe from the graph that this thing has origin symmetry. Okay, but when you look at this equation, you're probably like, well, this doesn't match the yellow equation. Okay, so you can simplify this. Okay, you may not know how to, so I'm going to show you. Okay, all right, watch what happens here. Okay, I'm going to simplify this. I'm going to work under the cubed root. Okay, so I've got -y is equal to, under the cubed root, we have -x. That is the same thing as -1 times x. Okay, and then there is this rule. Okay, I'm going to show it to you now. You may have seen this before, and it's actually going to come back in this class, so it's good to kind of start early with knowing this. If you have any kind of root, square root, cubed root, fourth root, fifth root, whatever, okay, and you're multiplying underneath the root, you can break it up. So the cubed root of -1 times x is going to be the same thing as the cubed root of -1 times the cubed root of x. Okay, you can do that. Okay, all right, so if you're multiplying underneath a root, you can break it up into two different roots that you are multiplying together. All right, we still have -y on the left. All right, so in the next step, okay, looking at the right side, the cubed root of -1 is just -1, because -1 times -1 times -1 is -1. Okay, so the cubed root of -1 is equal to -1. Okay, that's going to be -1 times the cubed root of x okay? And then what we can do is we can either multiply or divide both sides by -1, okay? So I'm going to take this side and divide by -1. Whatever I do to one side, I have to do to the other, okay? And then what you will see is this negative sign will cancel with this negative sign. That will leave you with positive y is equal to, on the right, this negative sign will cancel with this negative sign and leave you with positive cubed root of x. Okay, and so this purple equation is the original equation. So yes, the graph of this particular equation has origin symmetry. Okay, so in conclusion, the snake graph, y equals the cubed root of x, has origin symmetry only.